Hi, this is Dwight Honstein from Rhino Security Labs, and today I'm going to be demoing a tool that I've made called SleuthQL. SleuthQL is a SQL injection discovery tool. SleuthQL is not just another SQL map. In fact, it doesn't aim to do what SQLMap does at all. Rather, it's a tool to help discover potential SQL injection points. So, what do I mean by that? I mean that as an assessor, you're usually doing your web application audits through a proxy like Burp Suite. What this aims to automate is the manual analysis work that we do as web app pen testers in the discovery of names and values that match database-like syntaxes. This list of database-like syntaxes is pulled directly from some documents of MySQL and MS SQL, and it aims to match via regex query parameters and values that have known bad strings in them. So, for example, user ID could be a potential SQL injection point because it has ID in it and a preprinted string. Or values such as, select star from where clauses, maybe other miscellaneous database keywords being used in a value could be a flag for a potential SQL injection point. So why do I need this? The reason that I like to use a tool like this over, say, Burp Pro's scanner is that SQLMap will often find injections that Burp Pro scanner simply cannot. And we could run SQLMap across the entire website, and there are extensions to do that, but that is slow and time consuming. So let's go ahead and jump into the tool. So I've just cloned this tool. We see this from a previous run. Let me move these. So we have our tool here. It's powered by Python 3. And we need to install the requirements. So we need to do pip3 install requirements. I already have the requirements installed. And we see over here in our Burp Suite Community Edition that we have this test website already printed to the scope. So let's go ahead and populate our target data. To show the ease of automation, I'm going to go ahead and spider this host to get the full list of URLs and allow it to do some post requests and things like that. While that runs, SleuthQL will be able to parse parameter values from the URL, from post bodies that are regular www URL encoded, from multi-part form data, and from JSON content types. What it can't do and what it won't do is search cookies for potential vulnerable parameters, and it won't search nested data structures. So that'd be things like a get query param whose string contains a JSON object that is also has a value of a base 64 encoded JSON object. That it cannot do right now. So the spider's done running. So we need to export all the site data for SleuthQL to run on it. So we right-click, save selected items. We'll save it as vulnweb.com. Okay. We probably should move vulnweb.com here to actually vulnweb.xml. So let's run the tool. We see that we need to pass it a comma-separated list of domains. And then we also need to pass it the proxy XML target tab history. The TAC-v flag is to show any errors that are encountered via at parse time. So if there's a request that has a misaligned content type, you'll see that, and it won't be added to the list of requests to parse. So we need to pass it the domain flag, TAC-d, which is vulnweb.com. You could also do the subdomain if you wanted to. TAC-f, vulnweb.xml. So it parses the XML, it loads all the requests from the proxy history, it will filter down those requests to those only matching the designated host names, and then it will spit out a list of results. So this result list is sorted by domain name. It will then give you the method, the path, as well as the vulnerable parameter, or the potential vulnerable parameter. For artist, it's artist. For cart, it's price. Add cart. Comment, AID, PID, name, PHP action, etc. So this is useful as an assessor from the top-down view if you want to go through your burp and manually find that request. And in terms of automation, we now see that we have a new folder called vulnweb.com. So if we navigate to this folder, we have a list of raw request files that was parsed from the burp target history. So when it identifies a potentially vulnerable parameter, it will automatically add the custom SQLMap injection point to the end of the value of that parameter. So we see here for it believed artist was a potential vulnerable parameter, and the injection marker here is at the end of 3. We can look at some post ones as well. Let's look at less post, cart, PHP 0. We see that, yep, add cart is maybe, price could be potentially 1 point. So let's go ahead and run SQLMap in batch against all these files. So all these are request text files, so find star.txt, and we're going to execute SQLMap in batch. We're going to pass it the request file, and because this is a test website and we know the backend database, we're going to pass it DBMS MySQL, and we're going to let that run. So if you were an assessor and you just wanted to let this run, say like overnight, you could just let this go, and then you could parse the log file at the end when SQLMap is done. So we see that we've already found a potential injection point. So for the sake of this demo, I'll be stopping it after this run. Let this go. Okay. So if you were to let this run overnight, you could do cat SQLMap output and then the website along with the log, and you're going to grep for injection. And see what we actually have. Identified some injection. Let's give it some context. And perfect. So that's the demo, and I hope you enjoyed.